Hello, welcome to Easy Math. My name is Ishan, and today we're going to look into sketching of trigonometric curves. This video is going to be in two parts. One video we're going to look into sketching of sine and cosine curves and the questions related to it, and the other video is going to be about tan curves, and of course, there's going to be questions explained which have appeared in the past papers. We're going to discuss them. So let's start with sine curves. What I have here is a standard sine curve that may be asked. What I mean by the word standard is it's going to be of the form a sine of bx plus c. That's the form which is usually asked to sketch. Well, by simple comparison between these two, what I can see is A is supposed to be a 2, B is supposed to be a 3, and C is supposed to be a 5 here. Also, I've asked Desmos to sketch it for me, and there it is. That's the sketch Desmos has drawn for us. What I want you to notice here are a few things that we will use to sketch the curves when they're given to us. The first thing I would like you to see is the line y equal to 5. Look at that blue line. So I'm going to write the values of a, b, and c first. Well, a is a 2, b is a 3, c is a 5. And now let's look at this line y equal to 5. Do you notice that the curve goes up and down on this line? Do you see it oscillate about that line? Do you see the curve oscillate about that line? Well, that means that y equal to 5 is the principal axis for this sine curve. So location of principal axis is a very important thing. The other thing I would like you to notice is how far up or down this curve goes from the principal axis. Where it goes 2 units up, reaches a maximum of 7, and 2 units down from the principal axis reaches a minimum of 3. The point here is the amplitude for this curve is r2. That's the distance of the highest point. That's the perpendicular distance of the highest point on the curve from the principal axis. That's a 2 in this case. And of course, the lowest point is also the same distance away from the principal axis. Okay, so principal axis taken care of. Amplitude we have spoken about. Now, I want you to see the size of one wave in here. Let's see. Well, this is where I would start looking at the wave. There it is. There. That's one whole crest. And that's one whole trough on the wave. That's one complete wave from this place to that place. What is the size of it? Let's see. Starts from a 0 and gets to a 2 pi by 3. It stretches over a length of 2 pi by 3 on the principal axis. That's the length. Well, that is known as period of a wave, 2 pi by 3. Although technically there is a whole definition to it, but we are going to look at period as the uh, part of the or distance along the principal axis that the wave occupies when it moves. There it is. There. That's the distance it occupies on the principal axis. It's a 2 pi by 3, and that's what we'll call as the period of this wave. Okay. Now, let's see how these points, these points that we saw, were actually seen by just this formula. I said A is a 2, B is a 3, and C is a 5. What I saw is that the amplitude was R2. Amplitude was a 2 for this wave. Okay. I also saw that y equal to 5, which is the value of c here, was supposed to be the principal axis for this sine curve. And if you can pay attention here, don't you see that the period was a 2 pi by 3? Look at that. Look at how these numbers show up in the sketch. A 5, principal axis. A 3 shows up here in the period. Amplitude of 2, A equal to 2, shows up here in the amplitude. Look at that. And that is what we are gonna summarize about this sketch. And I'll show you the whole summary. Look at that. So whenever it comes to sketching of sine curves, I know that the principal axis is going to be at y equal to c, the amplitude is going to be equal to a, and the period is going to be 2 pi by b. Or if the measurements are in degrees, the period is going to be 360 divided by b. I will make sure that I have one random point also spotted on the grid for me to be sure about the sketch. For example, I'll take a x equal to maybe a pi by 3 and obtain the y corresponding to it. And I will locate a pi by 3 comma that value of y on the grid. Maybe it shows somewhere here, and that ensures what I have been drawing for the sine curve was actually correct. So it's just gonna serve as a guiding point for our curve to be correct. Okay. And when it comes to shape, once we look at some examples, we'll see how the shape is going to come about. What you can do here is think of some numbers and give it a go by yourself. Me, I'm going to take some numbers and we're going to see what it looks like. So I go take a equal to 1 maybe, or let's do a 2. 2 sine of, let's take a b equal to 2 and a c equal to minus 3 there. Okay. So the curve which is usually going to be seen in additional math, a sine of bx plus c, what I have done is I've taken a as a 2, b as a 2, and c as a negative 3 by my little chart that I have there. Let's bring that chart about here. Okay, where is? Hmm. Okay. So with that chart here, let's just compare. I know that the principal axis is supposed to be at y equal to c. C value is a minus 3 here. In that case, y equal to minus 3 is going to be the principal axis. There it is, the purple line, if you can see it here. And I also see that the a value is a 2 there. A value out there is a 2, which means that the amplitude of the curve is going to be a 2. For me, it means that the curve will go from the principal axis 2 units up and 2 units down. That is the extent of my curve, the curve that I'm going to draw here. Well, what is the location of the principal axis? Minus 3. For the amplitude being a 2, with a being a 2, the curve will go as high as a y equal to minus 1. There, you can see. It'll go 2 units up. From minus 3, it reaches a minus 1. How low will it go? 2 units down from minus 3. Well, it's going to get to a y equal to minus 5. Well, there it is. These are the guidelines for me to draw the curve. There it is. I'm going to make these a little light, you know, let's say there. These are going to serve as the guidelines. So we have seen the principal axis, we've seen the amplitude, and now we're going to look at the period of it. The period is supposed to be 2 pi by b. B value for me is a 2, which means pi equals to 2 pi by b. Period is a pi. Okay, fine. What I do is I draw a vertical line at x equal to pi. There. Now that indicates the length along which one wave that I'm going to draw is going to stretch. Okay. Now I'm going to make this a little lighter again. I'm also going to decide one random domain for me to sketch it. Let's go do the curve between 0 and 2 pi. 0 and 2 pi. I want the curve only between 0 and 2 pi. Okay, fine. I've got the period. Period was a pi. I've drawn an indicator, a vertical line at x equal to pi. There it is, x equal to pi. I'll draw one more to indicate the last value of x that I may substitute into the curve. There it is, x equal to 2 pi. And again, I'll make it a little lighter. And there it is. Also, let's take one random point. How about we take x equal to pi by 3 maybe. Y is 2 sine of 2x minus 3. I substitute pi by 3 in here and I get a y equal to 2 sine of 2 pi by 3 minus a 3. Okay. I know that sine of 2 pi by 3 can actually be found without the calculator. I have been discussing the unit circle with everybody. There are videos where you can go and see how one can obtain sine of 2 pi by 3 without a calculator. Huh? Well, on the unit circle, 2 pi by 3 is going to be somewhere there, basically a 120 degrees. Okay. And it's the reflection of 60-degree line about the y-axis. The point is this point and that point. These two have the same y-coordinate. On a unit circle, the y-coordinates are supposed to be sine of theta. There. I know sine of 60 is a root 3 by 2, which means the same y, it's going to be for this point, and it's going to be equal to sine of 60, root 3 by 2. There it is. So when I find out 2 sine of 2 pi by 3 minus a 3, I go 2 times root 3 by 2 minus a 3. That's root 3 minus 3. And of course, I will find it and locate it here. Let's see. Pi by 3, comma, sine of 2 sine of 2 pi by 3 minus a 3. And it's a negative 1.26. So there it is. Sine of 2 pi by 3 is a root 3 by 2. Again, if you're not sure why sine of 2 by 3, 2 pi by 3 came out to be root 3 by 2. I would like you to check out the unit circle video and figure it out. And I know it's supposed to be root 3 by 2. And when you substitute it, you end up with a root 3 minus 3. And it's a negative 1.26. And there it is at a pi by 3. The point is we have one random point on the curve. All the guidelines and this point here will guide us about the whole sketch of it. Let's see. So I'm going to go, because it's a sine curve, remember, always start at the principal axis when x is a 0. So there is your starting point. Now you know that this is supposed to be one whole period, that whole thing, pi. So right around pi by 2, somewhere there is going to be half the wave. So you go up and down. That's one half of the wave. And you go as low as this particular value, which was, I think, minus 5. And then you go up, and there it is, one whole wave. I made sure that this particular point is also a point the curve passes through. I'll draw it again. Well, this time I want to be a little more fine with the sketch. There it is. And then I go do the curve, goes up, reaches the maximum point, goes down, reaches the minimum point, and then goes back up. And again, this is pi and this is 2 pi. Right in between them is a 3 pi by 2. I'll do the same. I go up and down, and then down and up. That's what my curve is going to look like. And let's ask Desmos to do it for us. I go between 0 and 2 pi. There. There it is. Now this is what our curve looks like. And this is their curve right there. Almost the same. Although that 3 pi by 2 is not uh, the same line I have. I'll remove mine and you can see. There it is. And then one particular point, you can see it's out there. So that's your curve, your sine curve. If the period was a pi, I made sure that one half of the wave is between 0 and pi by 2. Another half between pi by 2 and pi. And it goes on like that. Proper symmetry it follows. Also, I would like you to see the parts of this wave, from this part to that. That's 1/4 of a wave. From this part to that, another quarter. This part to there, third quarter, and that's the fourth quarter, one complete wave. These are little uh, parts of the whole wave. And of course, from pi to 2 pi, you have another whole wave out there. There are going to be two waves drawn for 2 sine of 2x minus 3. Okay. So that was one example. Let's take another one now. This time, we're going to take some fractional values on A, B, and C. Okay, let's check it out. So you can take a screenshot for this one. Keep it with you. The entire thing on the left here. And then we will take some we're going to take another example. How about we go this time minus pi to pi on the domain. A, I'm going to take as 2. B, I'm going to take as 1 by 2. Sine of x by 2. Okay, that's not correct. Okay, so I want it to be sine of x by 2. And minus 3 maybe. Okay, so there. Now, the thing is, if you want, you can actually go try it yourself. I don't mind. But the thing is, um, I'm going to compare. I'm going to compare and look for the values of A, B, and C. A, comparing it with A sine of bx plus a C, I know is a 2. B is a 1 by 2. C is a minus 3. Well, I know mm, the principal axis is definitely going to be at y equal to minus 3. I also know that the amplitude is going to be a 2. So the curve is going to go 2 units up from minus 3 and 2 units down from minus 3. Well, those are the boundaries, those are the boundaries which are going to bound the whole curve. There, minus 1, minus 5. I'll make sure that I have them lightly showing on my sketch, y equal to minus 5 and y equal to minus 1. Also, let's make them a little light. There, make them this light. You go there. Okay, these are the extents now. Okay, there y equal to minus 5, y equal to minus 1, and y equal to minus 3. And now comes the calculation for period. Okay, I know that b is a 1 by 2. I also know from my chart there, period is supposed to be 2 pi over b. Okay, fine. Period is supposed to be 2 pi divided by b. Well, 2 pi divided by 1 by 2. 2 pi divided by 1 by 2. That's 2 pi multiplied by 1 by 2. Oh, sorry, multiplied by 2. That's a 4 pi. 4 pi is the period for this curve. Okay, no problem. What I do is I first get me the farthest uh, boundary for my one whole wave to be contained. I go x equal to 4 pi. That's one whole wave. I know there's going to be one whole wave between 0 and 4 pi. On the left, I'd go minus 4 pi. There. I know there's going to be one whole wave between 0 and 4 pi and one whole wave between okay, it's not symmetrical. There. Something like that. I'm expecting it to be between minus 4 pi and 4 pi. There it is, one whole wave between 0 and 4 pi, and the same one whole wave between 0 and negative 4 pi. But there's a problem. The problem is I'm not supposed to sketch the curve between negative 4 pi and 4 pi. It's supposed to be drawn between pi and minus pi. They've limited the domain. Okay, I will first locate where x equal to pi is and x equal to minus pi is. Okay, fine. These are the places. Well, don't you realize if there was supposed to be one whole wave between 0 and 4 pi, half of the wave is going to be between 0 and 2 pi, and quarter of the wave is going to be between 0 and pi. The point is, these curves are highly symmetrical. If there's one whole wave between 0 and 4 pi, there's going to be half of it between 0 and 2 pi. There's going to be 1/4 of it between 0 and pi. What a nice concept. In that case, if they have mentioned that the domain is supposed to be between minus pi and pi, I'll take only 1/4 of the wave between 0 and pi. What is 1/4 of a wave? Well, it will go up from that place and reach the highest point. It may have gone further to reach the principal axis at 2 pi, may have gone further to reach the lowermost point at um, 3 pi, and then back up to meet the principal axis at 4.4 pi. But these are not there anymore. Okay, fine. The same, it could have gone down, up, and like that. Oh, sorry. I'm going beyond the beyond the guidelines. So I am going to go up like that. That would have been the entire curve, the entire wave between 0 and negative 4 pi. But I'm supposed to be between 0 and minus pi on the domain. So I'm going to only take this part of it, this quarter of it. Okay. And that is why my curve is going to look like that. Only this quarter and that quarter. And there is your sketch done. I would actually want to show you what it looks like between minus 4 pi and 4 pi so that you're not confused with the way I am sketching it. There it is. Like I told you, one whole wave between 0 and 4 pi. Another wave between 0 and negative 4 pi. But since you only want it to be between minus pi and pi, there it is. Only this much of it. And this was not the usual kind they would ask 4 years ago. In the recent years, they have started giving out fractional values on A, B, and C. And that's about it. You should be able to sketch uh, the curves if these fractional values are given. Of course, I started from the principal axis when I went up. I could have taken one more point in the domain. I could have taken a pi by 3 maybe, pi by 3, comma, uh, let's take this whole thing. Here, let's do pi by 3. And there it is. Just to make sure my curve is perfect. Yes, it is a point lying on the curve. And that's how it is done. Now let's take up one cos curve. We do a 2 cos of 3x minus 2. And again, we go back to the chart. The period is the same as sine. There. Amplitude the same. Principal axis is the same. So where is the difference? We'll see. We'll see what the difference is. Y equal to minus 2. That's the principal axis. Period is 2 pi by 3. Amplitude is a 2. A is a 2. So you go y equal to 0. That would be the highest point. Y equal to minus 4. That would be the lowest point. And you go x equal to 2 pi by 3. And there it is. Between 0 and 2 pi by 3, I'm supposed to have one whole wave of cos here. Okay. Now, I'll take one random point. Let's take a pi by 3 maybe. X equal to pi by 3. Pi divided by 3 and obtain the y corresponding to it. I won't I don't do, I won't do any calculations here. I'll let Desmos do it. 3 in place of x, I'm supposed to have a pi by 3 minus a 2, and there it is, 1 point on the curve, pi by 3 and a minus 4. Okay, fine. Now, how do I start sketching the curve? I'll put up the limits also. The domain, I say, is supposed to be between 0 and pi. Let's take a 0 and pi on the domain. There. Okay. Well, the thing that you would want to remember about cosine curves is that they would always start at the highest point when x is a 0. Remember, when sine was supposed to be sketched, I started at the principal axis when x was a 0. This is where I would start. I'd go up and down like that. But when it comes to cos, I'm going to go start at the highest point, which is the upper line. We drew y equal to 0. That's the highest point. That's the line which contains the highest point the curve reaches. So I'll go start from here. Well, I know if this is a 2 pi by 3, half of it is going to be pi by 3. Okay, fine. So let's draw it a little neater. You go, half of it is pi by 3. And then you go start the curve. Well, if it's at the maximum, the only way it can proceed is go down to the principal axis. So it goes down properly following the symmetry. So you go like that, and then you go up, down the principal axis, and then you go up through the principal axis, and there it is. That's my cos curve. Now the question is, it looks like a V. How is that one complete wave? Well, that's one half of a crest, which could have been something like that. And this is, I'll show it to you, wait. There it is, 2 pi by 3. This one is pi by 3. Huh? You go draw one half of a crest, one half of a trough, another half of a trough, and then one half of a crest, one whole trough, and then half crests. That's one whole wave. I could have gone a little ahead like that. Starting from here, this whole thing and that whole thing would have been one wave. But I'm supposed to be between 0 and 2 pi by 3. I'm supposed to sketch one whole wave. How do I do that? Starting from the highest point. Well, I'll go draw half the crest, half the trough, another half of the trough, and there it is. That's one whole wave. Now you want to go from 0 to pi. Let's see where pi is supposed to be. X equal to pi. There. Okay. Uh, that's 2 pi by 3. How much more can I accommodate? Let's see. This is our x equal to pi, which is actually a 3 pi by 3. So what I'm seeing is one extra pi by 3 to get to our pi. Well, I can go from 0 to pi by 3. I can see it was this part out there. Well, I can go draw the same between these two. Well, there's one extra pi by 3, right? See, have a look. Pi by 3, pi by 3, and another pi by 3. So I could have gone like that. This is what my whole curve is gonna look like. There. I'll say it again. 0 to 2 pi by 3, one whole wave. How do you draw it? Well, there it is. 2 pi by 3 to pi, which is a 3 pi by 3. I go do 1/2 again. So there it is. That's what my sine cos curve is gonna look like. And let's see. There. There it is. Now look at it without the guidelines. There. The principal axis at a y equal to -2, highest y equal to 0, lowest y equal to -4, period y equal to 2 pi by 3, end of the domain x equal to pi. Huh? A period is a x equal to 2 pi by 3, and there x equal to pi. What do? Start, come down, 1/2 of a wave, from there to there, another half of the wave. That's one complete wave between 0 and 2 pi by 3. If there was no such domain on this cosine curve, it would have looked something like that. There. This is what it would have looked like. Endless curve. But I'm only supposed to take this much of it. So that's the entire thing. Uh, I will actually take one more example. Let's see. How about taking some 2 cos of 4x minus 3. Okay. And all of that between, let's do minus pi to pi. And I will also make sure that there is a fractional thing happening here. I would want to take x divided by 3 maybe. Oh, that's wrong. I want it to be between minus pi and pi. There it is. There. Okay, fine. I'll go as usual. Principal axis y equal to c. Amplitude is an a. Period is a 2 pi by b. You can take your time and pause the video here and try it yourself. Well, I'm going to go start. C value is a -3. Amplitude is a 2. A value is a 2. So I go as high as a -1 and as low as a -5. Those are my guidelines. I would also want to keep up the boundaries x equal to pi and x equal to minus pi. I'd also figure out what the um, period for this wave is going to be. Well, it's given by the formula 2 pi by b. The b value for me is a 1 by 3. There it is. It's a 6 pi. The period is a 6 pi. Okay, fine. Let's do a x equal to 6 pi. This may not be there, by the way. Your grid won't be as large as 6 pi on the right and -6 pi on the left. But now that we have Desmos, I'm going to use it. The thing is, I know cos curve is going to start at the top. 6 pi from here to here, I'm supposed to contain one whole wave. At 3 pi, I know it's going to be half the wave. So I go this way and there. That's one whole wave. On here, on the left, I go half the wave and then I go this way, like that. Hmm? There it is, x equal to 0. That's where the cos will start. Cos curve will start. At 3 pi, there's going to be half the wave. That's half the wave. And another half out there. There it is. And on the left, I'd go again 3 pi. So there it is. Somewhat like that. Hmm. That is what I'm expecting the cos curve to be like. Okay. But I'm going to have to draw it between minus pi and pi. So this little gap between 0 and pi is only supposed to contain 1/6 of the wave. A wave which would have gone. Okay, let's just locate x equal to 3 pi. First of all, x equal to 3 pi. Oh, there it is. Huh? A wave which could have gone here to here like that and then back up like that. I am only going to have this much of it showing on my sketch. And the same on the other side. Only this much of it. Only this much of it. It would have gone somewhere there. Minus 15, right? Somewhere there. So that is what it should have been. But only gonna see this much of it. This much of it. Okay, let's see. How do I find the ends? So let's get rid of the minus 6 pi. Let's get rid of them. Let's get rid of the 3 pi thing. Also, let's get these to look like they are little guidelines, light and color there. Hmm. These also I'll make sure are very light in color there. And this one also there. And let's figure out the value of y at x equal to pi. Okay. 2 cos of pi by 3 minus a 3. Well, pi by 3, cos of pi by 3, I know is 1 by 2. That's cos of 60. Cos of 60 is a 1 by 2 minus 3. I go 2 into 1 by 2, that's a 1. 1 minus 3, that's a negative 2. So there it is. At x equal to pi, I know x equal to pi, my curve is going to be at a negative 2. And of course, it follows symmetry. So there, it's going to be at x equal to negative pi. So my curve is actually going to go like that, like that. There. Okay, so let's see. Let's ask Desmos to do it. And there it is. A little curve. It looks like the top of a water tank. It's a cos curve. You can have a whole water tank down here. There, like that. The point is, looking at the domain, you're going to have to decide what portion of the wave is going to be accommodated, what portion of the wave is going to be seen in that particular domain. Of course, the period was a 6 pi. The whole wave is going to stretch from a 0 to a 6 pi. But minus pi to pi, it's only going to be uh, 1/3 of it. 1/6 on the right and 1/6 on the left. A total 1/3 of the wave is only going to be seen, although the entire thing may have been this thing. There, have a look. This is what it was supposed to be, but you are supposed to draw it for that little window. Huh? X equal to 6 pi. There it is. One whole wave, if you can see. There half, and this is the other half. How about x equal to minus 6 pi? There, one half and the other half. But no, this is not what they wanted. And that is why we have only this much of it showing. A very nice concept. You should practice, you know, to get these. Anyways, that's about it when it comes to uh, understanding how the whole thing is to be sketched. There it is. This whole thing you're gonna have to keep with yourself. Huh? Oh, okay. Okay, yeah, there. This thing is what you would like to keep with you, serving as a uh, guide for you to sketch. I could have taken one random point here also, over there, to figure out where the curve would go. Anyways, now we're gonna go and do some questions from the past papers. I'm taking the past 4 years of questions. There are 26 questions that I have collected, out of which 8 or 9 of them I'm going to explain right now. The rest is for you to do. Where would you find them? Well, in the description and in your Google Classroom, the description of the video and the Google Classroom, you will have them. You'll have the whole PDF of the questions. You're supposed to do them right away. Only when you go at the questions right after you've been in this video with me will you be able to do it. If you go give it some time, I am pretty sure you're gonna forget it, or maybe you're gonna have to watch the video again. uh, okay, let's see. See, there's gonna be two kinds of questions they may ask. Kind number one is where you're given a domain and you're simply supposed to sketch them. Kind number two is when they give you the sketch, and you know that form a sine of bx plus c. They'd say if the sketch of a sine of bx plus c looks like that, find out the values of a, b, and c. That's the other kind you're going to see. Both of them equally seen in number, both the kinds. Okay, so we're going to do 2 or 3 questions from each kind, and then we will let you do the whole PDF. This is the PDF, by the way, the one on the left here. There. This is the whole thing. Okay, so let's have a look. Let's look at a few of them from the kind number one. Okay, there it is. Again, I go. I know that there it is, a sine of bx plus c. If I compare, a is a 5, b is a 1 by 2, and c is a 4. If I rearrange it in the same form, 5 sine of theta by 2 plus a 4, that's a sine of bx plus c. C is a 4, a is a 5, and in place of theta, I have a x in here, and b is a 1 by 2. Okay, fine. So I'll make sure that these things show up on my sketch. Okay. First, we go spot the principal axis, y equal to 4. There it is. Then I'll go look at the amplitude. It's a 5. So I can go 5 units up from 4. And there it is, the other guideline. Remember, you're never gonna be given marks for the guidelines. Okay, I'm just trying to be better at sketching by using these guidelines. If you become a pro at it, you don't even need them. Huh. When you are in a practice of drawing the guidelines and do it in the exam, make sure that these guidelines are not that dark or not that visible in your sketch. I'll draw them with a very light color. 5 units down from 4, I'll reach -1. So there is the other line. And also the period is supposed to be 2 pi by b. I know that the b value is a 1 by 2, which is 4 pi. I know that pi is supposed to be 180. So there it is. 720 degrees is supposed to be the period of it. So from a 0 to a 720, which may be somewhere out there, you're only given a 360. So 720 may be out there. So one whole sine wave is going to be seen between 0 and 720. That is what it may have looked like. But I'm only supposed to draw it between negative 360 and positive 360. So that doesn't hold any significance. This part of it, this part, that one that I drew, doesn't hold any significance. Okay, so I'll go draw one half of the wave between 0 and 360. So I'll go start, like I told you, from the principal axis at x equal to 0, go up, reach a maximum, come down to the principal axis. That's one half of the wave. And then I'll go do the same on this side. There it is. And there is my curve. Done. One whole wave between negative 360 and 360. That's 720, which was supposed to be the period. And yes, I have it there. If they had asked me to show them the intercepts of the x-axis, I would have found them also, these two. But they didn't. So I'll stop it here. That's my sketch. Okay, let's look at another one now. I could have taken one more point, by the way. Let's take it at 180. So you go 4 plus 5 sine of 180 divided by 2. That's a 4 plus 5 sine of 90. That's a 4 plus 5. Now, sine of 90 is a 1, and it's a 9. Of course, you'll find that y is a 9 on the curve that we have already drawn. So it is correct, just to verify. Okay. Fine. Now let's look at another question of the same kind. Here it is. Quickly, we have done this earlier. Here, the principal axis is a y equal to -1. Amplitude is a 2, so y equal to -1. There it is. I'll spot the principal axis. Amplitude is a 2, so I can go as high as a 1 and as low as a -3. There it is. And then I'm going to look for the period of it, which is 2 pi by b, or a 360 by b if the angles are given in degrees. B is a 1 by 3. This comes out to be 360 divided by 1 by 3, which is 360 times 3, 360 times 3. Well, that's a 1080. And you are supposed to have it drawn between negative 360 and positive 360. So that's only how much? How much of the curve? How much of the curve do you think it's going to be between 0 and 360? 1/3 of the curve. Okay, fine. It's a sine curve. No problem. I'll start from here. And negative 360 to 360, that's a whole of 720 out there. What I'll do, just to be a little better at my sketching, I will locate the locate some random points. For example, I'll take x equal to 180 minus a 1. That's a 2 sine of 60 minus a 1. That's a 2 times root 3 by 2 minus a 1. That's a root 3 minus a 1. And that's about a 0.732. I know root 3 is a 1.732. So when it's a 180 on x, It's about a 0.732, so I'm somewhere there. At a 270, let's see. The domain is too large. It's a 1080. And the period is too large. The domain is too small. So I'm going to take one more point. X equal to 270. Let's see. 2 sine of 90 minus a 1. Sine of 90 is a 1. 2 minus 1. There it is. Somewhere there at a 270. I'll also find it at 360. Let's see. 2 sine of 120 minus a 1. X equal to 360 means x by 3 is a 120. 2 sine of 120. Sine of 120, we have already seen, is root 3 by 2. So you go 2 sine of, that's a root 3 over 2 minus a 1. That's a root 3 minus a 1. And again, a 0.732. So 36, and there it is, a 0.732. Am I? Wait, hold on. I think I have obtained the values wrong. Just a second. Okay, so the thing is, I think we got this thing wrong at 270. So we're going to correct it quickly. So you go 2 sine of 270 by 3 minus a 1. That's a 2 sine of 90 minus a 1. That's a 2 minus a 1. It's actually a 1. So at 270, you're somewhere here. Well, that roughly gives you the idea. The curve is going to go, and I can also find it at 90 degree. Why not? 2 sine of 90 divided by 3 minus a 1. That's 2 sine of 30 minus a 1. That's a 1 minus a 1, a 0. And there it is. The curve goes like that on the right. And of course, it's going to be symmetrical on the other side. So it has gone to a 0 from minus 1. It will go somewhere here. And then at 180, it will reach somewhere there. At 270, it will reach that place. And at negative 360, it will reach somewhere there. And there it is, your entire curve between. Now, the thing is, we followed a different pattern for this question. And the thing is, when the domain is very small compared to the period was a 1080, you're supposed to draw only one third of the wave. It would have been pretty large, it would have been pretty large from there. It would have gone up and then down and then up like that to complete one wave out there. But we're only supposed to do little pieces of it. So that is why we went point by point, joined them by a smooth curve like that, and you'll get yourself the whole curve. Very nice. That's about it. Let's look at another one. And there. Look at this one now. Okay. Now y equal to 1 is our principal axis by simple comparison. The amplitude is a 5, so you can go as high as a y equal to 6, and as low as a -4. So there it is. Those are the guidelines. Amplitude of 5 here shown, amplitude of 5 here also shown, and the period is gonna be 2 pi over b. It's a 2 pi over 1 by 2. It's a 4 pi. Hmm. Okay. So between 0 and 2 pi, there's gonna be only one half of the wave. Okay. So it's a sine curve. So I'll go there and here. There it is. Done. Only one half of the wave between 0 and 2 pi, and another half between 0 and negative 2 pi, a period of 4 pi properly shown. That's about it. Okay. I would have done this one, but I think it has been stretched a little too far, is it? Fourth one there. Okay. Between 0 and pi, mod of cos of 2x. Okay, I will do it. Between 0 and pi, Uh, Again, if I compare it with a cos of bx plus c, I don't see any c value there, which means c is a 0. So I go there. That's the principal axis. Amplitude is 4. So I'd go as high as a 4. 1, 2, 3, 4. There. And I'll go as low as a minus 4. 1, 2, 3, minus 4. There it is. You'd see that I'm not paying attention to the mod of 4 cos of 2x here. I'm only considering it to be a pure 4 cos of 2x as of now. And the mod part of it we'll address later. Once we have the curve for 4 cos of 2x, the mod part of it we'll address later. For now, giving the coordinates of any points where the graph meets the axes. Oh, that's also a very nice thing to show. Okay, so I go the period where let's find out 2 pi divided by b, which is a 2, so period is a pi. So I'm supposed to have one whole curve between 0 and pi, one whole wave. Cos curve, like I mentioned, starts from the top there it's gonna go right around pi by 2. It's gonna reach half of it. Well, I'll also find where it meets the x-axis, meaning I'll solve for 4 cos of 2x equal to 0, meaning cos of 2x is a 0, 2x is a cos inverse of 0. Well, that's a pi by 2. Well, x is supposed to be a pi by 4 in that case. Well, there it is, pi by 4. 2x is a pi by 2, x is a pi by 4. And of course, it's going to be there. So I'll draw in blue the curve. It goes like that and then goes back up. But the thing is, 4 cos of 2x is not what I'm supposed to do. I'm supposed to do the mod of it. In that case, I'll take the part which is above the x-axis as it is, these two. And the part which is below the x-axis, I'm simply going to reflect it about the x-axis. And there, the one in red is the curve that is actually going to count. And there it is. Done. I'll bring back the whole thing. You can see. This was 4 cos of 2x. One whole wave between 0 and pi. And then the part of the curve which was below the x-axis was reflected to get the mod. The red curve is what's going to count, and you're going to get the marks for. They said they want the coordinates to be given. So I'll go do a pi by 4 and a pi. This is a pi by 2. This is a pi. So, of course, this is a 3 pi by 2. Oh, sorry, I'm wrong. Pi by 2 and a pi. What lies between pi by 2 and pi? Well, we're going to have to see pi by 2 and pi divided by 2. That's 3 pi by 4. 3 pi by 4. There it is. 3 pi by 4. The one in red is your curve. So there it is. Your entire curve. Okay, now let's do a few questions of the other kind where you're supposed to find out A, B, and C. Okay, let's see. Uh, okay, there it is. They say that the curve is given by this and it passes through these 2 points. And the period is a 2 pi by 3. Well, when the period is a 2 pi by 3, and I know period is always given by 2 pi by b. In that case, 2 pi by b is equal to a 2 pi by 3. B is a 3 in there. Done. I get the value of b right away. It's a 3 by simply comparing 2 pi by 3 with a 2 pi by b. Again, let's see what else can be obtained. It passes through the points. Okay. How about I substitute the x values in here, and I know that the y corresponding to it should be a minus 2. Let's use the first point. negative 2 being y, a cos of b I have just found is a 3, and x, when y is a negative 2, is supposed to be a minus pi by 6. So there it is, minus pi by 6 plus a c, a negative 2, a cos of negative pi by 2 plus a c. Again, coming from the unit circle, I know minus pi by 2 is out there. This is the point. The x coordinate of this point on the unit circle will be a 0, which means cos of minus pi by 2 is a 0, which means minus 2. This whole thing goes because cos of minus pi by 2 is a 0, is a c. There it is. C of value also obtained by one of the points. C is a minus 2. Okay. Now we go take another point. Y is a 1 by 2 when x is a pi by 9. There it is. 1 by 2 equals a cos of pi by 3 plus a c. Well, I know, oh, c value I've already obtained. It's a minus 2, so I don't need to continue with a c there. Now, here we are. This negative 2 can move to the other side. Add a as it is. Cos of pi by 3. Cos of pi by 3. I already know it's a cos of 60, which is a sine of 30. So you're supposed to have a 1 by 2 out there. There it is. 1 by 2 plus 2. 1 by 2 plus 2 is a 5 by 2. 5 by 2 equals a by 2, which means a is a 5. Done. A is a 5, b is a 3, and c is a negative 2. Done. Okay. That was one example. Let's look at another one. Okay. This is a nice one. Oh. This they are saying is a cost curve. ABC values are to be found. Well, do you realize that the C value is supposed to be the place where the principal axis is, y equal to c. That's where it is. Well, my curve looks like it has a period of 960, already mentioned. Okay, that is one point we can use. The principal axis, I don't think I'd be able to locate it. Okay, let's see. Period, which is already given, it's a 960. Well, I know the formula for it. 360 by b is the formula for it. B is supposed to be 360 by 960. Well, if you divide both of them by a 60, it comes out to be a 120 is far better. I'd go 3 by 8. That's your b value. 2 pi by b, 360 by b is the period, which means b is a 360 by 960. It's a 3 by 8. So I have my b value at least. Okay. I also see that when x is a 0, y is a 6. Okay, I'll use that. Y equal to a cos of bx plus a c. I go y is a 6 when x is a 0. Well, 6 is equal to cos of 0 is a 1, a plus c. Okay, fine. I've got one equation at least between a and c. I'll use this point also, where x is a negative 320 and y is a 0. This is a negative 320 comma 0. Okay, so I'll use that. We'll use that in a different color. Y equal to a cos of bx plus a c. Y is a 0 when x is a negative 320 plus a c. Well, there it is. 0 equals minus 40. These two cancel out. That's a minus 40. Minus 40 into 3 is a minus 120. A cos of negative 120 plus a C. Well, negative 120 on the unit circle would be somewhere there. I'm supposed to find the cos of negative 120. That's the x coordinate of this point. Well, I know it's the rotation of this thing, a 60-degree thing, by 180 degrees to reach there. That's negative 120. Okay. What is negative 120 going to be? The cos of it. It's going to be cos of 60. Cos of 60 is a 1 by 2. It's a negative 1 by 2. Done. So there, a times negative 1 by 2 plus a c is a 0, which means minus a by 2 plus c is a 0, which means a is a 2 times c. And I'm going to substitute a equal to 2c out there. So 6 equal to 2c plus c, 6 equal to 3c, c comes out to be a 2. And of course, a being 2 times c is going to be a 4. So a is a 4, c is a 2, b equals to 3 by 8. Well, you saw I used the points on the curve to figure out the values of a, b, and c. I got a simultaneous equation in a and c, and I used that to solve all the values of a, b, and c. That's about it. Okay. And there are many more examples. What you can do is you can try them all. Huh? This whole PDF I'm going to attach. I have done the question number 1, 2, 3, 8, 14, 17. Tan curves, by the way, you don't want to do here. We are going to address it later. And we have done about 1, 2, 3, 4, 5, 6 questions out of 26. There are 20 questions for you to do. 2 of them are tan, which means 24, 20, 18 questions for you to do. You can do at least 10 of these and get back to me. And let's see if this whole sketching of thing has made sense to you. Huh? We'll see. And that's it for today. I'll see you, and do update me about how these questions have come about after you've watched the videos. And of course, like and subscribe and stuff like that. I'll see you. Bye.